One of the most exciting buzzwords in artificial intelligence is neurosymbolic systems. This describes combining the capabilities of neural systems based on deep learning, where you have deep neural networks that produce vector representations of high-dimensional data and can also perform some reasoning abilities like question answering or fact verification using these deep neural networks. Then you combine this with the symbolic systems, where you use things like logic and relational algebra in order to query your datasets with things like relational database systems like the SQL and GraphQL systems. This tutorial is going to show you how to use the Weaviate GraphQL API to achieve neurosymbolic functionality and neurosymbolic queries on your dataset, combining vector searches based on deep learning representations with symbolic filters. This tutorial is going to walk through roughly 10 demo queries to help you get up to speed with the GraphQL syntax and get started with using this really exciting development in artificial intelligence, a neurosymbolic database system. Our first example is to retrieve some property from objects in our database. We have three different functions we can use in the Weaviate GraphQL API: get, aggregate, and explore. What we're doing here is we're getting and then one of the classes stored in our database. So data objects in the GraphQL system are stored as class property. So we have publication, and publications have properties such as the name of the publication. Now here's where the GraphQL part comes in. The GraphQL is really good at linking these objects together so that you don't need to do several different REST API queries to return the different classes stored in your database. So publications have another class, articles. So you'd say name has articles, and that links to the other class property object of articles. So you have publication name as being one of the properties, and then it would link to the other objects such as articles, which might have a property like the content of the article. So here's a simple query for how you can return some property from one of the classes. So we use get publication name, and it returns the names of the publications in our database. As mentioned previously, our publications have articles. So when we have a publication like the Wall Street Journal, it contains these articles, and the articles are probably the more fine-grained objects being stored in our database. So articles is another class property object where it has properties like title. So here we're in this GraphQL query, we're getting the name of the publication and the titles of the articles that are in that publication. So we get a much longer result from the query as we go through the entire publication and return all the titles of all the articles that are contained in each of the publications. This next query further demonstrates the ability of GraphQL to link together the different objects stored in the database. We're linking together publications with articles with authors, the three objects in our GraphQL schema, where each object is stored in a class property structure, where authors have the property name, articles have the property title, and then probably the content of the article, and then publications have a name as well, in addition to the properties of linking them to the other objects in the schema. So in this, what we're doing is we're adding limit 3 to only return the first 3 publications. As we saw previously, if you list all the different titles and all of the articles in all the publications, you end up with a massive return data object. So now what we're doing is we're chaining together the publication. It has the articles, return the title of the article as shown here, and then also give us the name of the author of the publication. So we're showing how to link between, go from publication to articles, and then articles links to the author. The first 3 query examples showed the basics of returning some property of the different class property data objects stored in our GraphQL schema, and then how to link together the different objects by using these properties that say links together the different objects, as seen with has articles and has author. So now we're going to be introducing the symbolic queries, or the scalar filters. So now we're getting the article, and we're going to be returning the title, summary, and word count of the article. These are the properties of the article that we're returning, but now we're introducing this symbolic filter to our return data from this database query. So what we're doing is we're saying where the word count is greater than or equal to 1,000, and then limit to just 10 articles that satisfy this property. And we return the title, the summary, and the word count of each of the articles that match the symbolic filter. Before getting into the neural vector search, here's a look at the aggregate function. Previously, we looked at the get function, where we return the data itself, compared to the aggregate, which is going to do this meta-analysis of the objects in our database. So we can also use the aggregate function with the neural searches to do meta-analysis on what matches our neurosymbolic and our neural queries. So what we're doing here is we're counting the number of publications, the number of authors, the number of articles, as well as returning some statistics about the word count. And this particular part of returning the meta-analysis is something that a neural network system on its own would never be able to perform. If you were just trying to, say, train a deep neural network to sum up to get the maximum mean numbers of word count stored in some kind of GraphQL data schema. This overall would be kind of an absurd task for a deep neural network, say supervised learning system, compared to using these symbolic filters where this is an extremely easy task. Now we'll get into the headline event, performing neural vector similarity search. We're doing this by using the near text function of the text vectorization module in Weaviate. The Weaviate modules are where you package together deep learning functionality. So in this case, we're just using our vector similarity search or our vector distance search with this concept argument to the near text function. So we're going to be looking for, in our title and summaries of our articles, concepts that match the vector embedding of money. So the way this works in deep neural networks is money is going to be embedded into a text vector representation. Say a natural language processing model produces these vectors of, say, 512 dimensions. We're going to be comparing these 512 dimensional vector embeddings of our concept that we pass in as an argument, which in this case is money, to the vector embeddings of the title and summaries of these articles, and then we're going to limit the first 10 matching data objects that match this query. So we're using the near text functionality of our text vectorizer to find similar vector embeddings in the title and summary of these articles that match money. So we see as we run the query that we return articles based on money. And this is really interesting because you can add any kind of thing to this concept and it will match it with the articles. Here's the real headliner of this tutorial on GraphQL, the first neurosymbolic query that we're using with the Weaviate GraphQL API. So we understand how we use the text-to-vec module, where we use the Hugging Face transformers in order to produce vector representations of whatever we pass in as the concept and whatever we're passing through to search through, whether it's the title and the summary. So now we're also adding the symbolic filter of the word count. So we have our vector neural search on this concept of ride sharing in the articles stored in our massive database. And then we have this symbolic query that the word count has to be greater than 200 and it has to have the regular expression tax, so like taxi, in this symbolic query. And then we limit it to the first 10 and we return the title, summary, and word count of articles that match this query. So as we perform that, we only return 2 articles that have a word count greater than 200, contain taxi in the title. Flying taxis are about to take off at last. And then we also have this concept of ride sharing. So we see each one has this concept of ride sharing. So we don't have to label our databases with the concepts that are contained in the articles. We can pass in whatever kind of description we want for the concept and it'll find semantic vectors that match this semantic vector embedding of the concept. Another interesting property of these semantic distance searches is when you want to group together instances that are very similar on the vector semantic representation. So this idea of merging together the different publication names helps you cluster together publications that are roughly similar. So as we show with this example of grouping the publications with this force factor, we group together the New York Times and the International New York Times. So we can change this force. If we make it smaller, it doesn't group them together. And if we make it stronger, then it will grab more articles in the cluster, or even stronger than that. But so this could be useful for whatever we're returning from our database, whatever we're searching for. If we want to merge together semantic neighbors to form these clusters, and we just want to return clusters rather than say we're searching through something like 1 million academic paper titles, we're going to want to merge them together into titles and not just return the entire list of papers that match. And it's different than, say, using the limit query, because this lets us have the different clusters and get a better sense of what's happening. That concludes an overview of the 8 demo queries in Weaviate's Quick Start Guide on the documentation with the GraphQL API. Here's another interesting example from how Weaviate's GraphQL API was designed, published in Hacker Noon. So I think one quick difference between this example and the previous example is this introduction of things compared to actions, which I think has been deprecated, although I'm not exactly sure about that. But so we have get product where path in stock is less than 100. So we're at a grocery store and we have less than 100 of these items in our grocery store, and we want to return the name of these items and how many of them are in stock. So this originally returns these different things in our grocery store, and then we further want to add the filter that they're a fruit. So we can use the concept fruit and we use the explore instead of the get or aggregate function to only return the fruit, and the certainty is another filter that we can apply to these neural searches where we're seeing some distance threshold to return it. So we would only return banana and pineapple, but just another example of how we can think of combining these neurosymbolic filters, the neural filter of using the fruit concept, where you don't actually have to label all of the items in your grocery store as fruits or whatever they are. It can do this kind of semantic search with the deep learning models. That concludes the introduction to the GraphQL API to show you how to perform neurosymbolic and neurosymbolic queries on your dataset using the Weaviate GraphQL API. So what's next is going to be to show you how to do this with your own custom datasets. The previous example used the Weaviate console with the endpoint in the demo dataset of news article publications, and pretty soon Wikipedia will be added to this endpoint as well to play around with these demo GraphQL queries. So next we're going to be looking at how to add your own custom datasets, and I'm really excited to debut this project, Bird. I've been working on this for a while. It's a paper that's been accepted for publication and is currently going through all that camera ready stuff as it is formally published. But basically what it is it's a collection of articles all around the internet about Keros. So we're going to be doing this same idea of doing similarity search, where we have concepts like, say we want to search for few-shot learning loops in Keros examples all across the internet. Or say we want to look at using the gradient tape interface with Keros examples, or we want to say look at all the different ways that model architecture, say you want to see how GANs have been implemented, how conditional embeddings have been implemented in different Keros examples all across the internet. So I think this will be a really interesting project to get a sense of how to use your own custom data set and the power of this vector and symbolic search to explore these data sets. Thank you so much for watching this overview of the GraphQL API in Weaviate. I'd be more than happy to answer any questions or comment on any ideas you have in the comments of this video. Thanks again for watching, and please subscribe to Henry AI Labs for more deep learning and AI videos.